Good morning, children. This is 10th Physics, Chapter 11, The Human Eye and the Colorful World. Today we are going to cover the topic atmospheric refraction. In the last to last class, we saw, and even in the last chapter, we saw refraction. So, refraction is the bending of light when it enters from one medium to another, right, children? So, or when it enters from a rarer to denser medium or denser to a rarer medium. So, in atmosphere also, this refraction of light takes place, right? Based on this atmospheric refraction, many phenomena are seen in our atmosphere. So, we will learn about the apparent position of the stars, the position of the stars that we observe is not the actual one, is not the real one, right? Actually, the stars are somewhere else. Next phenomena is twinkling of stars. The stars twinkle due to atmospheric refraction. Then, based on atmospheric refraction, we will explain why the planets do not twinkle then. And finally, we will come to the last phenomena, and that is advanced sunrise and delayed sunset. Right? So, let's proceed with the atmospheric refraction. Now, you will say that, ma'am, in air, how can we have a rarer as well as denser medium? Yes, it happens, children. So, as we know that the atmosphere of Earth that is made up of different layers, right? That we have learned in our smaller classes. Now, what happens is, children, this is our, let me draw it with red. Okay, this is our Earth, right, children? This is our Earth. Now, the layers which are close to the Earth, they are denser. They are the denser layer because of the pollution, because of the dust, because of the all particles in the air, right? And the layers of the earth that are far away from the earth, they are comparatively less polluted, and so the smoke dust will be less. So they will make a rarer medium, and the layers of the earth that are closer to the earth, they will be denser because of the dust, pollution and carbon dioxide and many gases. So this is densely populated. Here you are going to have many gases. It is just a mixture, right, children? But far from the earth, the gases are not that densely populated, right? This is one concept. Or we know that the hot air rises, right? The hot air rises up. So the hot air from the earth, it rises up and it forms the layers of the atmosphere which are far from the earth. So the blue color layers are formed of hot air, and the yellow color layer, they are very close to earth, and so they are the cool air, because we know the cool air is dense, it is heavy, so it will remain at the bottom. But the hot air is less dense, it is light, and so it will rise up higher, right? And hot air is less dense, so we can say it is rarer, and cold air is very dense, बहुत भारी है, because बहुत सारे particles हैं, right? It is just a khichdi of everything, and so it is a denser medium. Okay, children. So from this we can say that the atmospheric layers which are very close to the earth are optically denser. They are optically denser, and the layers of the earth which are far from the earth, they are optically rarer. Okay, children. So we got here, children, two medium. One is rarer medium and another is denser medium. So when the sunlight will pass from optically rarer medium towards, this is our sun. So when the sunlight will pass from optically rarer medium towards denser medium, refraction of light will take place. Means there will be bending of light. Okay, so this refraction, which is caused by the different layers of the atmosphere, refraction कौन कर रहा है? Atmosphere की layers. So this refraction, which is caused by the different layers of the atmosphere, is known as atmospheric refraction. Now, you cannot, children, fix that if the rarer medium is there, then what is the refractive index for rarer medium? Or if you are having the denser atmospheric layer, then what is its refractive index? No, because children, we know air is moving, the dust particles are moving, the gas particles are moving, they are in constant motion, so they do not remain fixed anywhere. So the conditions are not constant in the air. So as the physical conditions are not constant, so the refractive index of the atmospheric layers is not fixed. It keeps on changing. Right, children? So this is about atmospheric refraction, that in atmosphere, the layers which are far from the earth, they are optically rarer medium, and the layers of the atmosphere which are close to the earth, they are optically denser medium. So the sunlight undergo refraction when it passes from rarer medium to denser medium, and this is known as atmospheric refraction. The conditions of the layers are not fixed, as the air, the gas molecules are in constant motion. So its refractive index keeps on changing constantly. And because of that, we get fluctuation in the apparent position of the objects. Whatever is present in the sky, we get their apparent position only. We do not get their real position, right? It may be star, it may be planet, it may be sun, any object in the sky. Right, children? So this is your atmospheric refraction. Now let's go for the first natural phenomena that is caused by the atmospheric refraction, and that is the apparent position of star. The apparent position of star. Now here, children, you can see in the diagram over here that this is the apparent position and this is the actual position. So actually the star is at this place, right? Actually the star is at this place, and when you see, you find the star to be over here. Yes, so you can see that there is difference in the position of the star. Why does this thing happen? Why do you see the apparent position of the star and not the actual or the real position of the star? Now let's come to this point. Now, as we all know, children, that here we are going to have rarer medium far away from the earth, and this is denser medium, right, children? So, when the ray of light, we have studied this in the previous chapter, when the ray of light travels from rarer medium to denser medium, it will bend towards the normal. It will bend towards the normal. So, children, so let me zoom the diagram. I think this much is enough. Okay, so children, here we can see when the light is coming like this, right? Light is coming like this. Now, air, it is formed of different layers. So, as it is coming from rarer to denser, it is going to bend. It will not go straight like this. It is not going straight like this. It is bending, right? Again, when it reaches at this point, again refraction occurs and again it bends towards the normal, means it does not go straight like this, again it is bending. Again from here it does not go straight like this, again it is bending towards the normal, right children? These are the normals that they have drawn, right? Again it is traveling, but no, it's not going straight. Again the layer changes, the refractive index changes, and again it bends towards the normal. So children, here we can see that the ray of light which is coming from the star is constantly bending, right? So as the ray of light which is passing from rarer medium to denser medium undergoes constant refraction, that is bending towards the normal, so we are not able to see the actual position of the star, but what we see is the apparent position of the star, right children? So let's read this out. Okay. So, so we know refractive index of atmosphere is increasing from top to bottom because we have rarer medium over here and denser medium over here. So the refractive index is going to constantly increase. So as the light from the sun that is coming, is traveling from rarer to denser. So it is going to constantly bend towards the normal, and as a result the star appears to be higher than its actual position. So star when seen near the horizon appears slightly higher than their actual position. Star is actually here, but to us the star appears to be over here. That is, it appears to be actually higher than the actual position due to the atmospheric refraction. Right children? So this is it, that why do we see the apparent position of the star. Next is twinkling of stars. Next is twinkling of stars. Now children, we know stars are very far from us. So we can say them as a point source, that is a point from which the light is coming. So stars are very far from us, so they are the point source. Now we know that the condition around the atmosphere, the condition in the earth atmosphere is constantly changing, and so light has to travel from these changing different layers, right? The layers are constantly changing because air is moving here and there, air is in constant motion, so the light has to travel from this constantly changing conditions of the atmosphere, and so it results in the fluctuation, that there is fluctuation, right children? And because of this fluctuation also only we are able to see the twinkling effect, right? Now what happens? Let's read further. The amount of light that is coming from the star varies due to the atmospheric index of the atmosphere. Now, refractive index constantly change hoga beta. So, As the refractive index will change, how much light from the star will enter our eye will vary, right? So sometimes the star will appear brighter because more light from the star has reached our eyes, and sometimes the same star will appear to be dull because less light came from the star to our eyes, and because of both of this, the twinkling of stars takes place. So in the initial part, you have to tell that star is a point source, and then you will say that the atmospheric conditions are changing, they are not fixed, and so there is fluctuation. And then you will talk about the amount of light that is coming. The amount of light will change with the changing refractive index. It will appear bright when more light comes. It will appear dull when less light comes. And combined effect of both is the twinkling of the stars. Right, children? Next is why planets do not twinkle. See, children, planets are not as far as stars. They are close to Earth. So, as planets are close, if you see some object is very close to you, suppose your NCRT, or suppose you are having very SL means physics at 12th, some some reference book you are having that is very thick and that is kept quite close to you. You will say, oh my God, such a big book. But if the same book is far from you, it is lying on in another room and you are able to see that book lying over there, then the book will appear to be smaller, right? Initially the book was closer to you, and so it did not look as if a point size. It was not a point size, right? So same thing happens with planets. Stars, they are very far, so they appears to be point size. But planets, they are close to the Earth, and so they are not point size. They are, here we have missed a word, they are an extended source of light. Point size का opposite होता है बेटा extended source, right? They are not point size, they are an extended source of light. Extended means they are made up of a number of point size. बहुत सारे point size मिलके क्या बनेगा बेटा? Your planet. You can consider it like that. Now, when the light comes from so many point size particles, then what will happen? See, planet is made up of a number of point size particles. So from when a number of point size particles, the light enters your eye, the average will be zero. The average will be zero. And as the average is zero, you will not see the twinkling of planets. The fluctuation part will go away, because if one source is fluctuating, might be at the same time another point source is not fluctuating. So suppose there are 50 point sources which are fluctuating and there are 60 point sources which are not fluctuating. So if you combine them, beta, if you see the average effect, then average effect would not be that much twinkling, right? So the average effect will be nullified, and so we do not see the planets twinkling. So this is the reason why planets do not twinkle. The last topic of today's class is advanced sunset and sunrise. So children, the sun, it appears to us, it becomes visible to us 2 minutes before actually the sun has the actual sunrise. Okay, 2 minutes before only we are able to see the sun, and during the sunset the sun has set, but then too for about 2 minutes after the sunset also we are able to see the sun. So it means the sun is visible to us extra 4 minutes. That 4 minutes sun is actually not present, right? But still it is visible to us. How does this happen? So the same atmospheric refraction takes place. So we will see it from the diagram over here. And let's concentrate on the diagram. See, here the sun is rising, right? This is the horizon. Horizon is the line of sight, the line of observation. जिस line में हम observe करते हैं, right? उससे below हम observe नहीं कर सकते. वही हमारी line of sight है, right? This is your horizon. Now, the sun is actually over here, but the sun's light, it is traveling again from a rarer medium towards a denser medium, right children? So again the refraction of light will take place. So the rays will bend towards the normal, and so the sun appears to be little higher. The sun appears to be little higher from its actual position because of atmospheric refraction. So the sun becomes visible 2 minutes before the actual sunrise, right? The same thing over here. The sun has set. Here you can see the sun has set, right? The sun is already below the horizon. We cannot see below horizon, right? Only horizon is our line of sight. Now what will happen? The rays of light that are coming from the sun, again they travel from a rarer medium to a denser medium. So again they will bend, and when they reach our eyes, we feel that the sunlight is coming from point S2. So again you can see that the sun appears to be higher. The sun appears to be above the horizon even after the sunset. So this is because of the atmospheric refraction. So when the sun is below horizon, the rays have to travel from rarer to denser, and so bending takes place towards the normal. And because of this, the sun appears to be higher than the actual position. Right, children? So this is it, children.